Hi everyone, welcome to the next section of the course, data mining techniques used in recommendation engines. In this section we'll look into popular data mining techniques such as neighborhood-based techniques, mathematic model techniques, machine learning techniques, classification models, clustering techniques and dimensionality reduction, vector space
Section
models,
4 Data mining
evaluation
techniques used in recommendation
currently used in
engines.
building
Subsection
recommendation
1 Neighborhood-based
Now we move on
techniques.
to the first
As
video of this
introduced
section,
in the previous
neighborhood-based
sections,
techniques.
the neighborhood methods
In this
are
video,
very
we're going to
simple
take a look at
techniques
the
which are
neighborhood
used
techniques
right from
like
the beginning
Euclidean
of building
distance,
recommendation
Cosine Similarity,
engines.
Jaccard
These are the
Similarity,
oldest
and Pearson
yet
correlation
most
coefficient.
widely used approaches
The
even
neighborhood
today.
methods are very
The
simple
popularity
techniques
of
which are
these
used
widely
right from the
used
beginning of
approaches
building
is
recommendation
because
engines.
of their
These are the
accuracy in
oldest yet
generating
most widely used
recommendations.
approaches, even today.
We know that
The
almost
popularity of
every
these widely
recommender
used
system
approaches
works
is
on the
because of their
concept of
accuracy in
similarity
generating
between
recommendations.
items or users.
We know that
The
almost every
neighborhood
recommender
methods
system works on
consider
the
the
concept of
available
similarity
information
between
between
items or
two
users.
users or items
These
as two
neighborhood
vectors,
methods consider
and
the
simple
available information
mathematical
between two
calculation
users or
is
items as
applied
two
between
vectors,
these two
and simple
vectors
mathematical
to see how
calculations
close
applied
they
between
are.
these two vectors
In
and
this
see how
section,
close they are.
we will discuss the
In
following
this
neighborhood
section, we'll
techniques:
discuss about
Euclidean distance, Cosine Similarity, Jaccard
Jaccard
Similarity,
Similarity,
Pearson
and
correlation coefficient. Euclidean
Let's first look at
distance.
Euclidean distance.
Euclidean distance
Euclidean
similarity
distance
is one of
similarity
the
is one
most
of the
common
most common
similarity
similarity
measures
measures
used to calculate the distance between two
or two
points or two
vectors.
vectors.
It's
It is the path distance between two points or vectors in the vector space.
In this
The
diagram,
diagram shown, we see the path distance between the two vectors A and B as Euclidean distance. Euclidean distance is based on Pythagoras theorem to calculate the distance between 2 points. The Euclidean distance between 2 points or objects, point x and point y, in a dataset is defined by the given equation. Here, x and y are two consecutive data points and n is the number of attributes for the dataset. How is Euclidean distance applied in recommendation engine? Considering a rating matrix containing user IDs as rows, item IDs as column, and the preference values as cell values, the Euclidean distance between two rows gives us the user similarity, and the Euclidean distance between two columns gives us the item similarity. This measure is used when the data is covered.
And you can see the result on your screen. Next we'll learn about cosine similarity. Cosine similarity is a measure of similarity between two vectors of an inner product space that measures the cosine of the angle between them. It's given by this equation.
Let A be a vector A1, A2, A3, A4 and B be another vector B1, B2, B3, B4. The dot product between these vectors A and B is given as. The resultant will be a single value, a scalar constant. What does it mean to take the dot product between two vectors? To answer this question, let's define the geometric definition of dot product between two vectors. On rearranging the given preceding equation, we get the following. In the earlier equation, cos theta is the angle between two vectors, and a cos theta is the projection of the vector A onto vector B. The visual vector space representation of the dot product between two vectors can be shown as in the screen. When cos angle between the two vectors is 90 degrees, the cos 90 will become 0 and the whole dot product will be 0. That is, they will be orthogonal to each other. The logical conclusion we can infer is that they are very far from each other. When we reduce the cosine angle between the two vectors, their orientation will look similar to each other. When the angle between the two vectors is 0, cos 0 will be 1, and both vectors will lie on each other, as shown in the image. Thus, we can say that the two vectors are similar to each other in terms of their orientation. So, on summarizing, we can conclude that when we compute the cosine angle between two vectors, the resultant scalar value will indicate how close the two vectors are with each other in terms of orientation. Now, let's revisit our original question. What does the dot product mean? When we take the dot product between two vectors, the resultant scalar value represents the cosine angle between them. If the scalar is 0, the vectors are orthogonal and unrelated. If the scalar is 1, the two vectors are similar. Now, how is this applied in recommendation engine? As mentioned earlier, consider a rating matrix containing users.
This is the R script for calculating the cosine distance. Here, X is matrix containing all the variables in a dataset. The cosine function is available in the LSA package.
The LSA is a package that we have already installed. Is a text mining package available in R used for recovering latent features or topics within the text. This package provides cosine method to calculate cosine angle between two vectors. Jaccard Similarity. Jaccard Similarity is another type of similarity measure used in recommendation engine. The Jaccard Similarity coefficient is calculated as the ratio of intersection of features.
The Jaccard Similarity coefficient metric is a statistic used to find the similarity and diversity in sample sets. Since users and items can be represented as vectors or sets, we can easily apply the Jaccard coefficient to recommender systems in order to find the similarity between users or items. This is the R script for calculating the Jaccard similarity.
R is a popular package for variety cluster similarities. It provides a very good implementation for calculating Jaccard similarity. Pearson correlation coefficient. Another way of finding the aforementioned similarity is to find the correlation between the two vectors. Instead of using the distance measures as a way of finding similarity among vectors, we use the correlation between vectors in this approach. The Pearson correlation coefficient can be computed as shown. Here, R is the correlation coefficient, N is the total number of data points, Xi is the ith vector point of the X vector, Yi is the ith vector point of the Y vector, X bar is the mean of a vector X, and Y bar is the mean of vector Y. Sx is the standard deviation of vector X, and Sy is the standard deviation of vector Y. Another way of computing the correlation coefficient between two variables is by dividing the covariance of the two variables by the product of the standard deviation given by rho. Let's understand with an example as shown in the figure. We plot the values of the two vectors a, b. It is natural to assume that if all the points of the vectors vary together, there exists a positive relation among them. This tendency to vary together or covariance is a simple terms can be called correlation. Take a look at the diagram. Now, let's examine the next image. We can observe that the vectors are not varying together and corresponding points are scattered randomly. So, the tendency to vary together or covariance is less or is in other less correlation. From the similarity calculation
As
aspect,
mentioned earlier,
we can
consider
conclude
a
that
rating matrix
more the
containing user
correlation
IDs
between
as
two
rows
vectors,
and
the
item
more
IDs as
similar the
columns.
vectors they are.
We can assume
Now
each
is
row
the
as user
how
vectors
is the
and
Pearson
each column
correlation
as item
coefficient
vectors.
applied in
The
recommendation
correlation
engine?
coefficient
As mentioned
between the
earlier,
row vectors will give the user
consider a
similarity,
rating
and the
matrix
correlation
containing
coefficient
your
between the
user
column
IDs as
vectors
rows
will
and
give the
item
item
IDs as
similarity
columns.
using this
We can
equation.
assume each row.
This is the R script for Pearson correlation coefficient.
Here, T-cars
Here,
is the
NT
dataset.
cars is the dataset. Great! In this video, you learned about the neighborhood-based techniques.